last part here is we want to be able to deal with functions in tables. Okay, so we dealt with function equations, functions with graphs, now functions with tables. Okay, so if I want to find out f of 0 plus g of 0, I just go straight to my table, f of 0. Okay, so I'm going to just highlight this in red. F of 0 is 0. Okay, g of 0 is 1. So I'm going to end up with 0 plus 1, that equals 1. F of g of 8, that means the inside is g, so I got to start with my inside. G of 8 is 7, and then I got to use this 7 as the input for my outside function f, so I end up with f of g of 8 equals 5. Okay, so again, make sure you understand how this flows through there. So this one here is now the inverse. So I have to inverse of g of 2. What does that really mean? That means the g of x equals 2. So that means my output is 2, and I'm doing an inverse. So I'm going from the output to the input. That's really 1. So I'm just better write this down. This is going to be f. This becomes f of 1. Okay, maybe I'll do that in green because it's coming from the green table, but that is equal to 1. And f of 1, if I look at my red table, f of 1 equals 1. How did I get that 1? Well, I interpreted this inverse. This g of inverse of 2 means that my output was 2, and my output was my old input, which was 1. Okay, so that's how inverse works. How about this one here? I take the inverse of f 15. That means that my output was 15 and my input is what I'm looking for, and I'm going to put the input into my f, and I want to know what the output is. Well, there is no 15 as my output here, so this almost seems impossible, except if you understand that the inverse of an inverse is back to where we started, this really just ends up being equal to 15. The inverse of the inverse just undoes it. Okay, it's like times 2 divide 2. Right? So if f is times 2, inverse of f is divide 2. So if I divide 2, then times 2, I undo them, end up back with what I started. So I'm going to put a star next to this one because this is important to know, because that's always a good way to, it's a simple solution because one undoes the other. There is a link for that as well, so you can see it geometrically as well on a graph if you want to see the inverse of an inverse. Okay, so this link actually refers to this problem. And the last one here, if I inverse 1, means the output is 1. I want to know the original input. Okay, well there's my output of 1. My original input then is 1. Okay, so then I'm just going to do this in steps. This becomes the inverse of g the inverse of 1. Okay, so what does this inverse notation mean? This means that this is the output, and I want to know the original input. Okay, if my output is 1, my original input must be 0. So then this must be equal to 0. Okay, so if I map it through, the inverse of f of 1, okay, that means that my output was 1, my input was 1, so then I go to the 1 here. The inverse of 1 means the output was 1, and I need to get back to the input, which was 0. Okay, so if we can understand how to map this on a table, this is something that we want to make sure we understand how to do as well.